Hello, people, and welcome back to another session. In this session, we'll be looking at an example to understand the basic concepts of one-way analysis of variance that we discussed in our previous session. So, just a quick 30-second recap. In our previous session, we discussed what is the fundamental concept of one-way analysis of variance, what is the null hypothesis and the alternative hypothesis that we are finding evidence for when it comes to statistical inferencing for one-way analysis of variance. We also saw what is the test statistic value for this particular hypothesis testing, and how do you calculate this test statistic using the variability of between and the variability of within. We saw how do you calculate the mean square between and the mean square within using sum of square between and sum of square within, and the degrees of freedom for sum of square between and sum of square within. And how do you actually go ahead and calculate your sum of square between and sum of square within? So our calculation starts from calculating sum of square between and sum of square within, and dividing these respective values with their degree of freedom to get the mean square, and then dividing the mean square values to finally get the test statistic. Now that this process is clear to us, let us go ahead and take a sample example. So here is an example. You have been given the observations of three different brands, Callaway, Nike, and Titleist. These observations, there are five observations for each, and for each of the groups, you have been given the mean, the variance, and the standard deviation. Now, what we have to do here is we need to calculate our sum of square between and our sum of square within. So let us go ahead and do that. So we discussed in the previous session, sum of square between is defined by the difference of the mean of the group minus the overall mean of the complete data set. So you have been given the mean of each group. You need to calculate the overall mean. Let us go ahead and do that. So you have three different groups. You have been given the mean of each group. So to calculate overall mean, you just need to add the three group means and divide that value by the number of groups. So we add 285, 260, and 290, and we divide that by 3. When you calculate this, you will get your value of the overall mean, which is 278.3333. Now in the next step, we'll be calculating our sum of square between. To calculate our sum of square between, you just need to multiply the number of observations in that group by the difference square of the difference between the group mean and the overall mean. Number of observations into the value of the group mean minus the overall mean, and we need to do it for all the groups. So if you look at my first group, the mean is 285. So 285 minus overall mean whole square. Then for the next one, 260 minus the overall mean whole square. And for the next one, 290 minus the overall mean whole square. And each you multiplied by the number of observations. So this is how you calculate SSB. To calculate sum of square within is a dual sum, as we saw in the last session. Basically, we need to subtract the value of observation, and we need to subtract the value of our group mean, the mean of the group from that, and we need to square this. We need to do it for all the points within the group, and then we need to do it for every group. So basically, if you look at this, what we are doing is we are taking first group Callaway, we are doing 280 minus the group mean whole square, plus 275 minus 285 whole square, plus 290 minus 285 whole square, all the way till all the 5 points are covered. After that, we'll go to Nike, 260 minus 260 whole square plus 255 minus 260 whole square, all the way till Nike is done, and then we'll do the same for Titleist. This is exactly what we have done here. If you look at calculation of SSW, this is exactly what we have done throughout. Okay, now to calculate my mean square between and mean square within, we need to take the sum of square between divided by the degree of freedom for sum of square. We saw in the previous session the degree of freedom for sum of square between is k minus 1, where k is the number of groups. We have 3 groups, so 3 minus 1 becomes 2. So it is SSB divided by 2. And mean square within is going to be sum of square within divided by n minus k, where n is the number of observation and k the number of groups. So number of observations are 5 into 3. 5 observations in each group. So 5 into 3 is 15. 15 minus number of groups 3, which becomes 12. So we do this. And then to calculate the value of F statistic, we do mean square between divided by mean square within. This will give you my F statistic, which is coming out to be 20.666, approximately 21. So this is how we calculate our value of test statistic. Now, we can say that the deviation of individual point from the overall mean is composed of two parts: the deviation of the individual point and the respective group mean, and the deviation of group mean from the overall mean, which is what we saw over here as well. You see, this is an individual point, and this is my overall mean. Now, basically, this deviation can be broken down into two parts: the deviation of this point from its group mean, and the deviation of the group mean from overall mean. So this is something that we have already seen in this example as well. And this is an important concept which we'll come to at a later stage. But all in all, the deviation of a point from overall mean can be described by the deviation of the point from the group mean and the group mean from the overall mean. So these are the two factors which will be always at interplay: the deviation between and the deviation within. We'll stop it here at this session. In the next session, we'll be continuing our analysis of statistical inference, and we'll be looking at an example of statistical inferencing for one-way analysis of variance in the next session. Thank you.